6 is on polar coordinates of complex numbers. So remember complex numbers, a plus bi, 2 minus 6i, complex numbers, i's. So we can have polar coordinates for complex numbers as well. So it says we usually represent real numbers using a real number line. So going back to the basics, real number line. Oops. Right, if we wanted to plot the numbers 1 and -2 and 0, right, we could plot all of these different numbers and they would have a certain order to them. Do you guys agree? 3/4, pi, √2. I mean, you don't have to do all these, but does this make sense? They have a certain order. Yeah. All right, so things get a little bit more complicated with complex numbers because complex numbers have what we call a real part and an imaginary part. Do you guys remember that from Algebra 2? The real part is the a, the imaginary part is the b. So the real part is the part without the I, the imaginary part is the part with the I. So for example, when you have 2 plus 3i, 2 is what we call the real part and 3 is what we call the imaginary part. And we didn't really talk about this too much in Algebra 2. I just said this is the real part, this is the imaginary part. But the reason that we do that is because we graph it on the real axis and the imaginary axis. So if I want 2 plus 3i, what I graph is the point 2, 3. So that represents 2 plus 3i. So it says the complex number a plus bi corresponds to the point a, b in the complex number plane. Okay? So you're going to have a real axis and you're going to have a complex, or like an imaginary axis. The number -5, if I have -5, well, isn't -5 really -5 plus 0i? So it would be plotted as -5, 0. The horizontal axis is called the real axis. The vertical axis is the imaginary, as I've drawn. Okay, so with that, we talk about the distance to the origin. Okay, so think about that. If I have this sketch up here, and I had 2 plus 3i, how would I get the distance from the point to the origin? Yeah, Pythagorean theorem, right? 2 squared plus 3 squared equals r squared, or whatever you want to call it, which is really just what we've been doing all along with vectors. We did it with our polar coordinates as well. It's really just the square root of x squared plus y squared, right? So that's going to be called the absolute value. I sometimes call it the modulus, okay? So can you guys all say that? Modulus. You got that down? You're not all going to say it. Modulus. Okay, so a modulus is just, or the absolute value, which is confusing too, because it's like, wait, what's the absolute value of a number? It's just the square root of, in this case, a squared plus b squared. So your x value squared plus your y value squared. So it's the Pythagorean theorem. All right, so the absolute value or modulus of the complex number a plus bi, we write it as z in absolute values, which seems weird, right? Does that remind you of vectors, though? Didn't we do that with vectors? And it ends up being the square root of a squared plus b squared. With vectors, you would see it with like lines like that, or you would have 2 lines. Do you guys remember what that was called with vectors? Not modulus, but it started with an M. Magnitude, right? All right. I don't know why I have this little grid here. Is it for the next one? Yeah, so find each absolute value. So if I have 5 plus 12i, do not just say, or 5 minus 12i, do not just say it's going to be 5 plus 12i, right? So many people do that on the test. It's not like an absolute value. You're not just taking the positive version of the number. Does this make sense? It means something totally different. So what we're doing is we're taking the square root of 5 squared plus -12 squared. So we get the square root of 25 plus 144. So we get 13. All right, square root of 169 is 13. Same thing here. So we're going to have the square root of 1 squared plus -1 root 3 squared. The signs don't really matter because you square it anyway. So we're going to have 1 plus 1 times 3, so 3. So we get the square root of 4, which is 2. Okay, that would be that. So it's basically like the magnitude of a vector. Okay, just like vectors as well, it says using the definitions of sine and cosine, we write cosine of theta equals, it was always like our x value divided by our r value. So it's going to be our a value divided by our square root of a squared plus b squared. All right, so if you have a picture, it's, well, I guess I should say a over r. Let me just write it as a over r. That will make more sense because I drew r in the picture. And then our sign was always the y value divided by our r value, right? So b over r. Therefore, a equals r times cosine of theta, and b equals r times sine of theta. Does it look familiar? Right? X equals r cosine of theta, y equals r sine of theta. And a plus bi then is going to be r cosine of theta plus I times r sine of theta. We put the I in front. Okay, this is the super important thing right here. So this is what we call the polar form or trigonometric form of a complex number. Okay, you'll be asked to do that lots and lots of times. So do we all understand that? It's just like a vector. The x is r cosine, the y is r sine. All right, to shortcut this, because it gets very annoying writing it out all of the time, is we sometimes will say r cis theta. What do you think the CIS comes from? Cosine I sine theta, right? So cosine of theta plus I sine of theta. So you might write it like that. So if you're lazy and don't want to write anything, you can do that. All right, the number r is the modulus, or the absolute value. Converting to polar coordinates allows us to multiply and divide complex numbers very easily. So do you guys remember when we would, in Algebra 2, we would do things like 3 plus I over 4 minus I, right? We did things like that. That wasn't that bad. It wasn't terrible. We would just multiply by 4 plus I on the top and the bottom. Do you guys all remember that? It was bad? You didn't like doing that? What if I made it this? Yeah. Would that be terrible? Yes, that would be awful. Like, we don't want to do that problem. Can you imagine? That would take forever. All right, so this is why we use polar form or trigonometric form, okay? This is why we learn this. It makes it much, much simpler. I promise, okay? So that's our goal. We're getting to that. I promise. All right, polar form. So it says every complex number, z, which is a plus bi, can be written in the polar form, z equals r cosine of theta plus I sine of theta, where r is equal to the square root of a squared plus b squared. Oh, wait. Which is really like the modulus of z. I should have written that backwards. Oh, I forgot my r. Yeah, you're good. Who got me on that one? Actually, we write it, I was kind of right. We really write it like this. We pull the r out. So really it would be I times r sine of theta. All right, and then a is equal to r cosine of theta, and b is equal to r sine of theta. And tangent of theta is always like our y value divided by our x value, right? So it would be like the b value divided by the a value. Okay, usually we say that theta is between 0 and 2 pi. However, there could be infinitely many choices for theta, and we understand that because you could rotate around the unit circle. You could put it in degrees. There's lots of ways we could write theta. Okay, just like with vectors and with our polar coordinates from before, you should always think about what quadrant you're in when you're finding theta. Okay, so it says express the following complex numbers in polar form and sketch the point. So if I have 1 minus I, okay, do we know how to sketch that? We have a real axis and we have an imaginary axis. What we're saying is we're going to go 1 unit along the real axis and we're going to go down 1 unit along the imaginary. It's going to be right there. So it's at the point 1 comma negative 1, basically. So in order to write something in polar form, or I might use the term trigonometric form, then we need to find r and we need to find theta. So r ends up being the square root of 1 squared plus negative 1 squared. So it's going to be the square root of 2. All right, theta, we find by doing tangent of theta equals our b value divided by our a value. Just like vectors. So we have negative 1 over 1. So if I want tangent of theta to equal negative 1 and I put this into my calculator, A lot of times I use degrees because it makes more sense for you guys when I use degrees. If I put inverse tangent of -1, it's going to give me theta is equal to negative 45 degrees. Do I want negative 45 degrees?
No, so you should add 180.
So I add 180. Not 180, 360 actually. Because it's in the fourth quadrant, exactly. So quadrant 4. So if I add that, I'm going to have 315 degrees. Do I still want to call it that? I want to use radians if possible. Yep. So we're going to write it as 7 pi over 4. So the trigonometric form, or polar form, is going to be r, which is root 2, and then we're going to have cosine of theta, 7 pi over 4, plus I sine of theta, which is 7 pi over 4. And that's our answer. Oops, I don't know what I just did there. That's crazy. It's like showing all my notes from all year. Okay. Got a little too close to that line, apparently. All right, there we go. Good? Do you guys understand the process?
I didn't understand how you got the answer, I guess.
It's always going to be in this form in the end. So you're going to have your r out front, and then you're going to have cosine theta plus I sine theta. It's the cis thing. You could write it as square root of 2 cis 7 pi over 4. If you want to write it that way. What is it?
The last one is the polar form.
Yeah, either they're both polar form. Like you can shortcut it. This CIS stands for cosine theta plus I sine theta. So it's the CIS. So we just shortcut it sometimes. Okay, so if I have 4 plus 4 root 3, what quadrant am I in? Yeah, quadrant 1, right? They're both positive. So I don't really need to, I guess I did say sketch the point. So you would go out 4 and you'd go up 4 root 3. So it'd be right there. I drew the big line there. Out 4, up 4 root 3. Okay, so we go through the same process. So we find r. We do the square root of the 4 squared plus 4 root 3 squared. So we get the square root of 16 plus, do you guys know 4 root 3 times itself, 4 root 3? Yep, good job, 48.
Do you not use the like I?
No, because you're just using a and b, those coefficients, not the I. All right, so we're going to have square root of 64, which is 8. All right, do you guys also know how you could find this without doing all of that work? What type of triangle is that, if you draw the triangle? It's a 45, 45, or not 45, you guys are confusing me. I started to say 45, 45, 90. It's a 30, 60, 90. Do you guys see that? So this has to be 8, and that's the length. That's what we're finding, r, the modulus, the absolute value. All of these things mean the same thing. So you could have done that by just noticing that you had a 30, 60, 90 triangle. All right, so then we say, well, our tangent of theta, which also you could find theta by recognizing that it's a 30, 60, 90 triangle. What do you guys think it's going to be? What will theta be? How many degrees? 60 degrees, right? Because the longer side is here, so it goes up higher than it goes over. All right, but we'll go ahead and do the work. So let's say we do tangent of theta, and we do our y value divided by our x value. We get tangent equals root 3. So if you did inverse tangent of root 3 on your calculator, it would give you 60 degrees, right? I said usually put it in degrees. It's easiest for you guys to recognize what it is. So our theta then is going to be, we're not going to do 60 degrees, we will do pi over 3. So we're going to end up getting r, which is 8, and we're going to have cosine of theta plus I sine of theta. So we're going to get 8 on the outside, cosine of pi over 3 plus I sine of pi over 3.
All these are equal to z.
Yeah, all of these are like the, it's rewriting whatever this, like if we called these z equals, it's rewriting it in another form. All right, are we able to do the next one without any calculations, just with our brains, just looking at it, thinking about the picture? Can we do it? I think we can. So the next one is negative 6i. So if you have negative 6i, that means you go negative 6 along the imaginary axis. Yeah. There's no triangle there, right? It's just the length. What's the length from the origin? 6. What's our theta? 3 pi over 2. That's it. So we say 6, and then we say cosine of 3 pi over 2 plus I sine of 3 pi over 2. And all of these, if you actually found what each of these things are, like if I found cosine of 3 pi over 2, what is cosine of 3 pi over 2? 0, right? So I'd have 6 times 0 plus I times sine of 0, or sine of 3 pi over 2 is -1. Do you guys see how you get -6i? You could multiply it out to check. It will always work. All right, and then 4 plus 3i. This is one that does not come out nicely. I think when it doesn't come out nicely, I let you leave it in degrees. I think I wrote that on there. The homework is not nice of me. All right, so here we go. So we're going to sketch it out. So I have -4, comma 3. So my point's right there. It's in the second quadrant. So my r is going to be the square root of -4 squared plus 3 squared. So it's going to be the square root of 16 plus 9. So I get square root of 25, which is 5. My tangent of theta is going to be the y value, which is 3 over the x value. So if I make sure my calculator is set in degree mode, so you guys can try it along with me, and I do inverse tangent of -3/4, or 3 over -4, I get theta is equal to -36.870 degrees. Do I like that number? No, that's not in the second quadrant, is it? It's in the fourth. Right, if you go back 36 degrees. So add not 360 this time. So right now I'm over here. I'm at a -36 degrees. So what do I want to add to get over here? 180, right? So I'm going to add 180. So when I do that, I really get theta equals 143.130. Oops, 0 degrees. Okay. So our answer then is going to be r, which is 5. So at least the r came out nice. Sometimes the r is not nice either. I would just leave it in its square root form if it's not nice. And then I'm going to have cosine of 143.130 degrees plus I sine of 143.130 degrees. And that is your answer. So it doesn't seem like it's going to be easier because you're like, oh, but that -4 plus 3i, that's so nice. It's so clean. But this polar or trigonometric form, whatever you want to call it, does make multiplication and division super simple. I promise. We're going to get to it. Okay? All right, let's do 2 more. So how about you guys try them? So try those 2. All right. All right, so if we're graphing this out, we're going to have root 2 and then -√2. It's going to be in that fourth quadrant. Now you went over the same amount that you went down, right? So what do you guys think this angle right in here is? Not 2. Angle, 45 degrees, right? Does that make sense? So you can do this one without doing all of the, a squared plus b squared under the square root. Well, you can still do that. But you can realize what your theta is without doing the tangent theta thing, okay? So for our modulus, if I did the square root of 2 squared plus -square root of 2 squared, what do I end up getting? Alex, you had it. You get 2. That's correct. All right, so 2 is our r value. So our modulus, or absolute value. Mm-hmm. And then our theta ends up being 315 degrees, or like we called it before, 7 pi over 4. Okay, so if I write out the trigonometric form, it's going to be 2 cosine of 7 pi over 4 plus I sine of 7 pi over 4. All right, and you could have written it with like 315 degrees as well. It doesn't matter how you write it, but I usually prefer radians, so I'll usually say between 0 and 2 pi. All right, this one does involve some math, right? So we go out 8, and then we go down -2. So our point's right there. So if I find my r, I'm going to have the square root of 8 squared plus -2 squared. So 64 plus 4. So we have the square root of 68. Does that go down any? Do you guys know?
2 root 17.
Yep, it is 2 root 17. Good job, Olivia. Yep, because 4 goes into it. 2 goes into it 34 times, so 4 goes into it 17 times. All right, and then our theta we actually have to find. So we do tangent of theta equals the opposite, or the y value divided by the x value. So I do inverse tangent of -2/8 or -1/4. And I get theta equals -14.036 degrees. Okay, usually I don't want that. I want it between like 0 and 360 if you're going to do degrees. So what we're going to do is we're just going to add 360 because it's in the right location. Like if you say -14 degrees, see how it's like starting on the x-axis and going backwards? So it's in the right location, but I just have to add 360 to get it between 0 and 360. So my answer is going to be 345.964 degrees. Did anybody get that? Good. So if you write it out, it's going to be 2 root 17, and then you're going to have cosine of 345.964 degrees plus I sine of 345.964 degrees. Do you guys see why we like the cis thing? It makes it a little bit easier writing, doesn't it? You don't have to write the long degrees. All right, and the very last one, it says, express the following complex numbers in standard form. So when you see standard form, what that means is a+bi form. And we're going to sketch the point. These are super easy. If it's like this, your first instinct as a math student should be, I want to simplify this. I know what cosine of pi over 3 is. I know what sine of pi over 3 is. Do you guys know them? Yes? What's cosine of pi over 3? It's 1/2, right? So we're going to have 2, and we're going to do 1/2 plus I, what's sine of pi over 3? Root 3 over 2, exactly, good. So when you multiply the 2 in, you get 1 plus root 3 times I, or I root 3 if you want. That's it. That's a+bi form. Isn't that easy? You just simplify. So if you're sketching the points, it would be in the first quadrant. You go over 1, and then you go up whatever root 3 is, like 1.7 something. And that would be your point right there. Easy enough? Yeah. Now the next one, we have 5.25. We don't have a little degree sign. It's in radians. Because there's no little degree sign there, right? All right, so we're going to change our calculator to radians. And when you have questions like this where they aren't unit circle values, you cannot get the exact value, right? Remember, exact values are square roots, fractions, and so on. We would round to the nearest decimal. So we're going to go ahead and find root 34 times cosine of 5.25 in radian mode. So I get 2.986. Oh, I don't know why I'm writing it like that. And I'm going to do plus root 34 times sine of 5.25. And that's going to be a negative number, so maybe I'll get rid of that plus and write minus 5.008i. Do you guys understand that? So I would be changing it into the other form. So you're really just multiplying it in. That's it. Think you can handle that? Pretty easy section. You might be able to even finish your homework. You got like 7 minutes.